To Database DevOps with containers. How do we get production data into production environments safely? I'm Rob Richardson, and here's the part where I tell you I am definitely going to post the slides on my site tonight. I've been following similar speakers, which is why you can go to robrich.org. Let's head there right now. .org, I click on presentations, and here's Database DevOps with containers. The slides are online right now, and the code is online right now. We'll get to see the code up on GitHub as well. While we're here at robrich.org, let's click on About Me and learn about some of the things that I've done recently. I'm a Microsoft MVP captain, a friend of Redgate, and a Jetpack developer advocate. If you're struggling to deploy to Kubernetes, one of the things I'm particularly proud of is AZ GiveCamp. AZ GiveCamp brings volunteer developers together with charities to build free software. We start building software Friday after work. Sunday afternoon, we deliver the completed software to charities. Sleep is optional, caffeine provided. If you're in Phoenix, or if you'd like a GiveCamp here in Italy, or wherever you're connecting from, hit me up on email or Twitter, or find me here at the event, and let's get a GiveCamp in your neighborhood too. Some of the other things that I've done, SQL Source Control Basics, that was a lot of fun. Mine is chapter 8. And one of the things I'm particularly proud of, I replied to a .NET Rocks podcast here, and they sent me a mug. Woo! So let's dig into Database DevOps with containers. How do we get production data into We talked about this guy. When we talk about DevOps, our goal with DevOps is to get reliability, consistency, and cost. A lot better at these types of tasks in a very consistent way, in a very reliable way, where people might get distracted. And computers are now cheaper than people. That wasn't always the case. Back in the punch card days, it was more effective for me to run the unit tests run them through that really expensive machine. Now that's no longer the case. It's more cost effective for us to run our units, run them through in our heads anymore. Computers are cheaper than people, more consistent, more reliable, and people to do, well, solving our business problems. So yeah, let's automate all the things because computers are cheaper and more reliable than people in this case. Let's take a look at a DevOps pipeline for applications. We'll come back to how that makes sense for databases in a bit. Now, we start with a customer suggestion and we end with customer feedback. Process that does include customer. Our goal is to deliver value to customers. So getting customers' input and delivering that value to customers is really important. Let's walk through this DevOps pipeline. We start with a customer concern. We might put that in a task tracking system, maybe Jira or Trello. As a developer picks up that task, they'll grab the code, make some changes, and commit that code. When they commit that code to source control, it'll kick off an automated build. Now, the automated build will not only build content, but it will also run through automation tests and finally deploy that content into, well, a pre-production environment. We might choose to run some additional tests here. Automated tests, maybe some of both. Once we get the thumbs up, we can deploy that content from our pre-production environment into a production environment, and now customers can start to experience that value as well. DevOps pipeline. It's really cool to be able to take new features all the way through and deploy them to. We have a failure here. So for example, we have a failure in our unit test in this case. We can take that knowledge and use that to build better software. Now in this case, maybe we're not going straight all the way back to the a customer suggestion with the task tracking, maybe this is just informing the developer to close that loop. But when we talk about shifting left, our goal is to move that failure as close to the developer as possible so that we can get that context so that the developer. It's always cheaper to find a problem closer to the developer than when we get all the way into production and now maybe data inform customers of concerns. Let's shift left to get this content as close to the developer as possible. DevOps pipeline for applications. Well, it's probably a system. If we were to lose everything else in this system, we could probably regenerate it. We run all of our tests, we deploy it, we validate it in a pre-production environment, and we deploy it to production. We're able to recover. If we don't have our source code, we're kind of stuck. DevOps pipeline for applications. If we switch over to a DevOps pipeline for databases, where's the primary copy of our system now? Is it in source control? It's probably not. If we were to lose our source control system, okay, we need to go figure out how to do that. But the main details that we need here are the production data. If we lose our production data, we're really sunk. Now, it's not even the production schema that's the most important, although the schema helps facilitate the data. It's really the production data that is the main piece of this infrastructure here. If we don't have our production data, we don't have the system. So how do we build a DevOps pipeline into non-production environments safely? Now I'm going to zoom in a little bit. We definitely want customers on either side where we want to deploy production data. Now we have production. We might have a DevOps pipeline that looks like this. Now in this case, maybe this is a disaster recovery DevOps pipeline. We're backing up production data and we're restoring it into production. We might also build DevOps pipelines for doing things like this. Let's take production data and move it into a pre-production environment. Now here we might have differences in hardware power. So maybe we need to trim out some of the database. We need to shrink it a little bit. Dev test environments, we probably don't want to leak secrets into those environments. So we probably ought to anonymize and sanitize this data as well. And especially as we get to developers, pardon me, as we get to developer machines, we definitely need to difference in horsepower of a developer's machine and anonymize production secrets in developer workstations, data, non-anonymized data in developer workstations either. Now we'll have different levels of anonymizing, sanitizing, and shrinking appropriate for each environment. If we were to anonymize, but if we were to not anonymize our data in a developer laptop, then that might. So with each of these steps, with each of these environments, we'll have a DevOps pipeline that will get production environments, and we'll do these tasks. Sanitize and shrink our data. Anonymize will remove personally identifiable information. Tokens and secrets. We don't want to just say, let's delete everything older than 6 months, or let's delete all the big things, because we want our data to have the same shape as it does in production, just less of it. So maybe let's prune the error logs. Maybe let's delete not the biggest customer, but maybe customers 6 through 10. Let's delete things that we want to keep the same wacky date into this, or want developers to be able to experience that setup. If a developer's query runs slowly on their workstation, they're going to optimize that query to run effectively. And when it runs with more data as well, probably. So we'll anonymize, sanitize, and shrink it appropriate for each environment. Then here's where we use our migration scripts or our migration processes, and that'll help us practice the schema migrations that we'll need to be able to push those into production. Now that process is definitely out of scope of today's talk to be able to take schema changes and push it into production. So let's migrate those, let's run those in, restore this into each environment. Hey, we just practiced a production deployment as we're doing a non-production deployment. Excellent. When we get to production, we already know that our schema changes will work. So we'll anonymize, sanitize, and shrink. We'll migrate to the latest version. And with all things, our goal is to automate all of the things. So how can we automate this process? How can we automate this? I would propose. Now let's dig into what is Docker. Let's hit it just in case. What are containers? How do we build them in an automated way? How is this better than VMs, Puppet, or Chef? Isn't Docker plus? Or maybe as C# devs, isn't it like VM sharp? Kind of, and not really. Docker is an ecosystem around container virtualization. Well, what are containers? Containers are lightweight kernel virtualization. We're not virtualizing the hardware like we do with virtual machines. Instead, we are virtualizing the operating system. So we have a lot lighter weight virtualization platform because we don't need a guest operating application. And so then Docker wraps this nicely with a suite of command line tools and a community that allows us to build these containers. Now, Docker didn't invent containers. Containers were here, namespaces, jails, C groups were here before Docker came. Docker just made it easy for us mortals to be able to create them. Now that's excellent. My analogy here is, what's the difference between ASP.NET and Ajax? Nope, what's the difference between XML HTTP request and Ajax? XML HTTP request and Ajax, from a technical point of view, are not different at all. It's exactly how we do it. Ajax just happens to be the request. But if we look at it less from a technical perspective and more from a user experience perspective, XML HTTP request powered Outlook web access in the 90s. Ajax powers Google Maps and Facebook, and that app that you're going to build tomorrow. Docker didn't build containers, but Docker makes it easy for us to, much like Ajax created a mechanism where we could asynchronously upgrade our web pages. Take a look at how Docker does things. On the left, we have traditional virtual machines. On the right, we have containers. On the left, we can see that when we need a new virtual machine, we need a new guest OS. 3 instances here. We have the guest OS, we have the dependencies, and we have our application. Now, in this case, we cloned the application so that we could have 2 copies of it running in our hypervisor. On the right here, we have Docker. Now we have a Docker hypervisor, much like we have another hypervisor like Zen or VMware. And here with this Docker hypervisor, we get the same sandbox. Processes can't communicate with each other directly. They must communicate over a network. So Docker provides. Now we have our dependencies and finally our applications. We don't need to do. So we can see that, and this graph is not to scale, hardware more effectively. Here we only got 3 copies of our. Now that's great. effectively when we run containers instead of virtual machines. Containers. Now, the cool thing about containers is they're able to virtualize the operating system. The downside to containers is they must match the operating system of the host. If the host is Linux, the guest must be Linux. If the host is Windows Server, the guest must be Windows. Now, what's missing? Well, what about Mac and Windows Desktop? What about Red Hat and what about GNOME and KDE? Desktop managers in Linux, and we're virtualizing Linux, so both of them will work fine. What about Red Hat and Ubuntu? Red Hat and Ubuntu are both Linux, the Linux kernel, not the Red Hat or the Ubuntu-ness built on top of it. So we can have a Red Hat host and Ubuntu guest, or an Ubuntu host and a Red Hat guest. We're virtualizing the Linux kernel. But if we have a Windows Server host, then we need a Windows guest. Well, what about Mac? What about Windows Desktop? In development, let's work like this. Now, this isn't how we want to do it in production. We want to do this in production like we do here on the right. We have our Docker hypervisor, and we're using the same operating system in both host and guest. So if this host is Windows, this guest is Windows. If this host is Linux, this guest is Linux. But in development, we may our Windows desktop machine. We'll install that OS. We'll install our hypervisor. In the case of Windows, this is Hyper-V, HyperKit, and then we'll install a guest OS. Linux OS. If we're using Docker Desktop, this gets installed automatically. Or if we're using WSL2, we can use WSL2's Docker running inside Linux. Now that we have Docker running inside Linux, we can. Now, because this is a hypervisor, Hyper-V or OSs, so maybe we'll run. This is how we do it in development on both Mac and Windows Desktop. This is how we want to run it in production, where we're getting as close to the metal as possible so that we can get maximum performance from our hardware. Now, Docker has built this really elegant ecosystem so that we can build and deploy these containers in a really elegant way. We start out with a Docker file. Now, this Docker file is configuration as code. It explains all the steps that we need to build our container. Now, with this Docker file, we can build an image. This image is a binary block. Do we need to put a file in this certain directory? Those build and configure steps are already done when we get to an container running on a hypervisor. We could think of this as source content and an instance of it. An object definition and an instance of an object. A Docker file will build an image. Now, we can share images with Docker Hub or another container registry, and we can pull things down from Docker Hub or another registry. And unlike GitHub or other types of repositories there, we're not sharing our source images, which means if I pull an image from Docker Hub, I don't need to recompile it. I just start it up as a container. Now, that could be really excellent for experiments. Let me just go pull an Ubuntu image, or let me pull a Redis image, and let me just fire it up and see how it works. And when we're done, we just delete that container, and there's no registry rot or any concerns on our machine. File, build an image, and run a container. We can use a Docker Compose file or Kubernetes YAML files to be able to specify many Docker files or many images up on Docker Hub or another registry. Pull or build those images, Docker Swarm or with Kubernetes to run all of our containers in context. Now, this Docker ecosystem can take a really lightweight file that just describes how our system is built and end up with a whole suite of containers running in concert to be able to host our applications. Here's an example Docker file that a developer might build to run a website. Now, in this case, it's an ASP.NET container, but we could do similar things or Java. We'll create some steps to be able to get our application into this container. Now, in a Docker file, there's various steps that we can go through: from, copy, run, and the last one here is CMD. The CMD line will run as the container starts. The rest of these are all the steps that we need to build it. So all these happen at build time, and this last one happens at runtime. In this case, we're copying our project, we're running .NET Restore, we're copying in all of our source code, running .NET Build and Publish, we're flipping over to our built directory, and we're starting our application. Come back here to this image. We can come over here to Docker Hub, and let's pull up this one. And once we land on this one, we can see the various details. Now, in this case, I'm using ASP.NET. So let's open that one, and we can see the particular details about this ASP.NET container, or this ASP.NET image, rather. Now, here's the 6.0 image, or if I'm pulling latest, and here's the Docker file that built it. So I'm up here on GitHub, and I can see all the steps that go into building this image. Now, it starts with this one, .NET Runtime. So we can come back here and we can go to .NET Runtime, and we can pull up that image. Now, the details with it has a Docker file, and we can open up that and see the steps that it's doing. And this one comes from .NET Runtime Depths. That's right here. And we can dig through each of these Docker files to be able to see the steps that they. Now, ultimately, we'll get to Scratch, but we can see how we've got this step where we're building a few commands that are standing on the shoulders of giants here with these other ones, and yep, turtles all the way down. That's excellent. We can build on top of various things set in place so that we don't need to worry about those concerns. Now, this is excellent. Once we start it up, we have this new read-write layer that comes into place for our container. All the rest out that some machines don't like having a read-only file system, so each container will get their own read-write layer. But each of these, so that we don't need to create a brand new instance and recopy all of this content for a second web server. We just start it up, Docker will cache each of these layers, and we're ready to go. So Docker is pretty magic. We can spin up hardware fast, we get our own host name and IP address, and we can NAT traffic from the host into this container. What's incredibly magic about this process is that inside the container, we can arrange config files just so, maybe hang the curtain folder on the desk, put this config file in this specific location, compile all our content to exactly match it. And then once we close the doors, we can think of it as a process. We can place limits on it. You can only use this much RAM and this much CPU, and we can restart it really quickly. As developers, we typically think about it as inside the container as a machine. As operations, we typically think about it outside the container as a process. But even better, we're using one set of tools to be able to do both things. That's really cool. So on Docker Hub, we can grab programming languages like .NET Core, Node, PHP, Go, Ruby, Java. We can also grab other things like data stores, Redis, PHPMyAdmin, WordPress, Postgres, SQL Server. Now, this SQL Server is a SQL Server Linux image that allows us to inside of Docker. That's really cool. A container. Now, SQL Server in production, you probably want to run Database as a Service. Let somebody else focus on just-in-time recovery and managing credentials and uptime. Let's outsource that all the night if the database goes offline. For on-prem, we've typically gotten directions to never run our content inside of a virtual machine. Remember those days? Well, now we're running SQL Server inside of virtual machines. And I would propose in time, we will start running our databases in containers. Maybe that day isn't today for you yet, but get ready because we will run our databases from inside containers pretty soon. In production, we want to run database as a service. Let's offload that to somebody else. In development and testing, we could run this mechanism a lot simpler. Now, what we want in a development or test environment is a dev-friendly thing, a restore of last night's production backup. We want this process automated. Have you ever been that DBA that gets that panic call from the developer saying, I need a new production backup. I just ran a query without a where clause. Yeah, if the developer could self-serve getting a new copy, because now the DBA can continue on with the task that they're doing and the developer can get their needs met as well. So let's build up a DevOps pipeline that gets our data from production into non-production environments, anonymized, sanitized, and shrunk. Now I'm digging into the code here. We've got an application that we can look at. We've got the schema that allows us to build up this database. And so in each of the tables, we've got various details, and then we have this database folder, and that's where we'll focus most of our time. This is our DevOps pipeline. VS Code, and we can see here, this is our script to be able to get data from production into non-production environments, appropriate for each environment. So let's take a look at our shortly after we finish a production database backup. So let's come here into production and let's back up our data. Look at this database, we'll see some interesting things. We've got a customer table, and this data comes from random user. Oh, that's not the execute. This data comes from randomuser.me. So these are not real users, but we can tell that we've got an email address here. Now, maybe we don't want to give our developers an email address. What if they're testing the email functionality and they accidentally send emails to real anonymize this data for the privacy of our users? Similarly, here's the settings, and we've got some production secrets, so we definitely want to sanitize this. Now, I also added a build date just so that we can see that when the build created this database, that might be helpful for versioning. Maybe we substitute this with an application version or a database schema build version. We also have an invoice log. Now, this invoice log might get really big. We probably want to shrink our data too big for our target machine. The shape of the data, so we want to change its shape, but just to change it. Maybe we delete customers 6 through 10. We're not going to delete the biggest customer. We want the data to be as weird as it is, but maybe we'll delete customers 6 through 10, and maybe customers 25 through 50. Let's get the database to be smaller without changing how weird the data is. So we've backed up our production database and we're ready for our DevOps pipeline. Now let's take a look at the script that we're going to do. The first thing we'll do is we'll restore our production database. And so we'll move that into place. And now we've got our database restored and ready to start anonymizing, sanitizing, and shrinking. And then connect to that random data. Now we might want to change other fields as well, but this allows us to anonymize our data to avoid leaking private information into non-production environments where we might have less control over it. Next, let's sanitize the data. Let's change our settings to dev-safe values. So I went and found this API key, I changed it to a dev-safe value, and I also changed the build date to today so that we could notice when we built this, when we last backed up this database. Next, let's shrink the database. Now in this case, we're shrinking it where 1 equals 0, so we're not shrinking it at all, but we can delete the data that we need to from various places to ensure that our application is performant when it gets to that target environment. Now that we've got our database anonymized, sanitized, and shrunk, now let's shrink the database files. So, and shrink the transaction log. And now that we've got our database in a much smaller file size, we're ready to move that into place. Now, if we had just deleted data but didn't shrink these files, then the container would still be as big as it was. Do we have in production and we want a 6 meg database in development? We need to shrink the files too. Now we want to go find some orphan users, so let's go set its password to a dev-safe password so we're not leaking the production. Allows us, then we'll set the SA password to a dev-safe password as well. Do our developers need to log in as root, as SA, to be able to manage the database? They can definitely do that on their local copy, not in production, but now they have control over the So this is that script that we sanitize and shrink our database appropriate for each environment. Now in production, this will probably do no anonymized sanitizing and shrinking. For pre-production environments, for dev test environments, and for development environments, we'll probably have an anonymized sanitize and shrink script appropriate for the level that we need to get to that environment. Now maybe they're the same, but maybe we'll want to tweak it a bit. Maybe in our dev test environment, we want more data so that we can experience more concerns. And in our development environment, we want to sanitize it more. Okay, so now that we've got this script, let's build a Docker file that allows us to launch this. So we'll start out with SQL, accept the EULA and set our SA password. Now, all else being equal, I would rather not set it here. I would rather inject it in from the command line. But for the simplicity of the demo, I'll just set it here. Then let's set our work directory to the temp directory, copy in our production database backup, and copy in our SQL script. Now we might map this as a volume, but copying it in doesn't hurt. We'll then start up SQL Server, accept the EULA, and sleep for 80 seconds. Now I'm sleeping for 80 seconds because I can, this command returns as soon as. Really unfortunate because I really wish there was an event to say when it was ready. I guess we could loop on a command saying, are you ready yet? But we'll wait 80 seconds to see if our database is ready. We'll use this environment variable from over. Let's see the demo. I just coded that password again. Then, so we'll run that script and then we'll kill SQL Server. Now we do have transactional integrity here because when SQL Server gets that kill commit and saved by the time it gets to this next process, and SQL Server is really good at trapping that to ensure that it has a very consistent state when SQL Server is stopped. Now, all of these commands create Docker layers, so each one would be cached. Therefore, after I run this command, the database is smaller, but the image is not. Because here, when we copy our production database backup, the full size of that production database backup is in place in this image. And so let's use a multi. Now we have a clean slate. We don't need our SA password because we used inside of our SQL command. Now we'll copy from the build stage. we'll copy from the build stage, choning to the correct user into this particular folder. Now that we've got our database in place, small image right here includes only those details that are anonymized, sanitized, and shrunk appropriate for our environment. We didn't grab the production database on this build image that we're going to throw away in a second. We image, or our development runtime image in this case, that is as small as possible. Okay, so let's run it. I'm going to come back in here. I've got Docker ready to go. And we're in this folder that has both our Docker file, our script, and our database backup that we just made. So let's run it. And I will call it dev database. And let's run it from the current folder. DevOps process is excellent. It's going to start by grabbing our production database backup, copying that into place. We've set our environment variables, passed them in perhaps. And now we're starting SQL Server. Now we're going to start the SQL Server and we're going to wait for that SQL Server to be available. Ideally, we would have a process that would go check in with SQL Server to see if it's available rather than time. But we can see as SQL Server starts up that we're doing some really interesting things. We're upgrading to the current version. So it started with 898 and it got to 904. Excellent. Our production database, it looks like our production, our SQL Server isn't quite up yet. Once it's up, then we'll start to run our script that will do that process of anonymizing, sanitizing, and shrinking appropriate to each environment. Now, so we might need a different script for a local developer workstation, different than our dev or test environment, different than our pre-production environment. Image that we want to set aside for disaster recovery. We've got this image in place, and so as soon as SQL Server is ready, we will go kick off that script to be able to get this process done. There we go. Looks like our database is available. So now we're going to go do that process. We've anonymized, sanitized, and shrunk our database specific to this developer workstation environment. We copy in that content, and now our database is ready to go. New dev database. Now it's 1.6. Server is pretty big, but if we look 5 gigs, and once Docker has cached that, the only differences that we need are the differences in our data, which looks like it's 0.1 gigs. That's all the data we have in our database. Excellent. So let's run this database as if we're a developer. Now, at the end of our DevOps pipeline, we might choose to Docker push this to a particular registry, and then switching over to our developer workstation. Did we just run a where clause that didn't work? Or do we want to catch up with the latest version? Docker pull that from our private registry, and we now have this dev database, Docker image list. We now have this dev database on our local machine. So let's start it up. Docker run will forward import 1433 into 14 database. Walk a developer through installing. Okay, so put in the image, start it up. Okay, click next. Now you want to pick these options. They're very specific. No, go back. All of that melts away because we're using our database through because our database is seeded with our. We've got that ready to go in our. Now it looks like our database is ready to go. So let's connect to it. Now, previously we're connected to our local database. Let's connect to our database that happens to be running in Minikube. So instead of local, we'll fire up Minikube. We'll put in our dev safe password here. And now we're connected. Copies our database from the layer in our image into our current read-write layer. And so if this is offline for a bit as you first started up, so let's come back to our script and take a look at the content that we've got. We'll use our web app. Now let's take a look at our customer data so that we wouldn't accidentally email customers. And it looks like we succeeded. We have a completely random but valid email address. If the user is testing email functionality and they accidentally send some emails, they won't go to our customers. To sanitize this, to remove production secrets and replace them with dev safe secrets. Because one of these config values is our build date, we can see that we built this database today. Excellent. Is your database version stale? Let's go take a look at the version of the container that you've got. Oh yeah, this is 2 weeks old. Do a Docker pull and Docker run and get this. And we shrunk our that was appropriate for this environment to make our database smaller. Now we didn't change the shape of our database. We don't want to alter the queries so that we remove how weird production data can be, but we do want to make it smaller. 6 through 10, 25 through 50. If our data in development is as weird as it is in production, then developers will build queries that better match the needs of production environments. So we got our production data into a non-production environment, anonymized, sanitized, and shrunk appropriate for that environment. Now in this case, we ran these commands from the command line, but we could just as easily incorporate this command into our Jenkins build or our GitHub Actions build. The moment our production database finishes, a production database backup finishes, we can do that Docker build and Docker push command. That a database backup is only as good as the last time you restored it. If we're doing this in a very automated way, every time a production database backup finishes, we're restoring it, then we are validating our production database backup every day. If this anonymize, sanitize, and shrink process fails, then we can't reliably depend. Perfect. We've just validated our database backup every day. Excellent. So we just add those commands, the Docker build and Docker push commands, to the end of our production database backup process, or maybe a job that kicks off just as the production database backup finishes. We'll add these to our DevOps pipeline, and we have a really elegant database DevOps pipeline that allows us to get production data safely into non-production environments. Now, as we look at this, we're using SQL Server on Linux in development. If we're using SQL Server on Windows in production, how is that different? Well, it isn't. One of the things that we did was we took our production database backup from a Windows SQL Server and we restored it over container. SQL Server on Linux and Windows are binary compatible. Now this includes the SQL CLR and Windows agent. That is amazing. The SQL CLR agent, the SQL agent and the SQL CLR work just as well in Linux and Windows. And in fact, Microsoft has committed that all features going forward will work equally on both. It's .NET Framework. .NET Framework runs inside of it. Yeah, that's pretty amazing. Machine learning and agent-based replication are now also in SQL Server on Linux. And there are some things that aren't on Linux. SQL Server reporting services and SQL Server analytics services. Both of these depend on IIS, which is not available on Linux. It makes sense that these pieces would move to Linux. So yeah, Those things that depend on Windows-specific components won't be available on Linux, but the majority of SQL Server is available on Linux. And so developing on Linux and running in production on Windows will be no big deal. In time, as we start to move our production environment into containers, then we'll also be in Linux. Database DevOps. DevOps for our applications. Let's also incorporate database DevOps for our databases. If we have does this process automatically, it frees up our DBAs to not have to chase developer requests for a new production database backup. We also validate developers. We get production content into developers in a very safe way. This is a really elegant mechanism that we can add to our DevOps automation suite. Database DevOps with containers. You can grab the slides right now at robrich.org together with the code. I would invite you to clone this Git repository and start to build your own database DevOps pipelines to non-production environment safely. And let's dig into all the pieces that you want to. For those of us live here at the event, what are your questions? What are your thoughts?
So there are no questions up to now.